Hello class, and welcome back. Talking about unconstrained optimization. That is, make the most out of limited resources or out of an opportunity without the presence of constraints or without considering constraints. In attachment to that, we also did some calculations of unconstrained optimization. In today's lesson, we are going to talk about constraint optimization. Now the question is, what is constraint optimization? We should understand that constraint optimization involves making the most of the limited resources or opportunity in the face of limitations or in the face of constraints. Making the most out of resources or an opportunity in the face of limitations. That's what constraints are. Now, we should understand that there are many constraints that firms face in their optimization quest. What are some of these constraints? These constraints may include, number one, lack of enough workers. The company may not have enough workers, so that's a constraint in the realization of its objectives. Number two, the firm may have limited raw material. That's a constraint in producing output level that may maximize the profit. What else? Lack of appropriate equipment. The firm may lack certain equipment that is required or needed to produce particular type of goods, or may have such equipment which may not be up to a standard that can produce at commercial level. Okay, what else? Lack of limited advertising budget. Now we should understand that advertising is one factor that promotes optimization of sales. Now, low budgets on advertising entails that you are telling less about your products to the world, and meaning the sales will also be less. Okay, let's continue. Constraints can be internal or external. So when we are talking about constraints, we are saying that these constraints can be internal or external. So when we talk about internal constraints, we are talking about a limitation that are inside. That is, if you have paid attention to what we were talking about previously, we talked about lack of material, lack of labor, lack of equipment, budgetary constraints. Those are internal. But there are also external factors such as maintenance of competitive advantage. You have got competitors that you have to match with. So those are external factors. Okay, what else? Internal constraints are those that are found inside the firm, while external constraints are those that are found outside the firm, as I've already explained. Now, two methods can be used to solve problems involving constraint optimizations. These may include, number one, we have the substitution method, SM, and second, we have a Lagrange multiplier method in which we use the lambda. Now, constraints are expressed in an additional equation containing the products in consideration and the actual limitation figure. So what we are trying to say here is that the constraint equation is expressed in addition to the objective function. So this constraint equation will have the products in consideration and also the actual limitation figure of production. Okay, now usually it will be given as a statement and requires you to formulate the equation. So usually this constraint equation is given just as a statement, which will require you to formulate an equation, a constraint equation. Now we'll talk about that later in our example. Let's continue. Let's talk about substitution method in today's lesson. What is substitution method? Now, the substitution method requires that the constraint equation is transformed into an unconstrained equation and then substituted into the main objective function. What are we trying to say? We are saying that this entails that one variable is made the subject formula. So you are going to have two variables, that is, one may be x, the other one may be y, standing for, and you will make one of those the subject. For example, x plus y is equal to 30. That's a constant equation. X plus y is equal to 30. Now, when we do the substitution, this will be, we will make x a subject formula, or the subject, or the y the subject. For example, x will be the subject, then 30, y will cross the equal sign, we'll join 30 that side, and it will be x is equal to y. So we have made x the subject of the equation, or possibly we can get that one, y is equal to 30 minus x, where y is made the subject, 30, then x crosses the equal sign, joins 30 here and becomes a negative, becomes y is equal to 30 minus x. Okay, example. That is an example that we have. We are saying Busuma Limited faces the following minimization problem. So the minimization equation, which is the total cost, remember total cost should be minimized in order for us to make profit. So the total cost equation TC is equal to 3x squared plus 6y squared minus xy. The question states, determine the cost minimizing output level of the commodity X and Y, subject to conditions that total output must be equal to 18 units using substitution method. So that's what I was saying, that the constant equation may be expressed as a statement in which you are required to formulate the equation now. Then the question B states that calculate the minimum total cost that will be incurred. Thank you very much. Let us go to the other side and now see how this question can be tackled. Okay, so our total cost equation TC is equal to 3x squared plus 6y squared minus xy. So we'll start with A. A is saying determine the total cost minimizing output level of commodity. Now that is in what I call an expression. That is in an expression saying determine the total cost minimizing output of the commodity x and y, subject to the condition that the total output must be equal to 18 units using substitution method. So we are going to formulate a constant equation, and that is x plus y should only give us 18. That's our constant equation. Now, we said in our notes that we have to make one of the variables a subject formula. So let's make x a subject formula. We are going to say x is equal to 18 minus y. So that is our constant equation. So we have created x a subject formula. Now what will happen is that wherever we see x in this our objective function, which is a TC, wherever we see the total cost equation, wherever we see x, then we should put 18 minus y. Now, most of the cases you find that your x, they will be at a point where your x will be squared. So this means that you are going to multiply 18 minus y by 18 minus y. So you can do that even before, so that we can just put a final answer of 18 minus y squared there. So let's do that. So we are going to say 18 minus y multiplied by 18 minus y. So 18 times 18, I like the calculator. 18 times 18 is giving us how much? It's giving us 324. 18 times 18 is 324. Then 18 times y, negative y is going to be minus 18y. Okay. Then we come to this. Negative y times 18 is going to be negative 18y. Negative y times negative y is going to be positive y squared. Right? Let's hope you are following. Now we are going to say 324 negative 18 minus 18. Negative 18 minus 18 is giving us what? What's the answer? Negative 36. So you are going to say minus 36y plus y squared. What does that mean? That's not an answer. It means that in our expression, TC is equal to 3x squared plus 6y squared minus y, y, where there is x squared, we are just going to put that figure, that equation. Where there is x, we are just going to put that. Okay, so we are going to take our total cost equation. Our TC is going to be 3 times, where there is x squared, we are just going to put 324 minus 36y plus y squared. We even close it, plus 6y squared, then minus, remember that our x is 18 minus y, so where there is x, we are going to put 18y minus y. Now, what I'll do, I'll put a y in front, then open bracket, 18 minus y, close bracket. Then I'll do the multiplication. Our total cost is going to be 3 times 2, 324. 3 times 324 is equal to 972. 972 minus 3 times 86 is going to be 3 times 86 is going to be 108. 108. Okay. 108y plus 3 times y squared is going to be 3y squared plus 6y squared minus, okay, negative y times 18 is going to be negative 18y. Negative y times negative y is going to be positive y squared. Then from there, we are going to collect the like terms. We're going to say TC is equal to, okay, so our 972, that one will just remain as a constant. Then our negative 108 is going to go minus 18y. That's it. Let's hope I've not made any mistake, because we are not going to find long figures. Next, we are going to say plus 3y squared plus 6y squared plus y squared. So our total cost equation is going to be 972 minus, this is y, this is 108y. So negative 108y times or minus 18y is equal to negative 126y. Then this one will be 3 plus 6 plus 1 is giving us what? 7. How come? 3 plus 6 plus 1 is going to give us 10, yes. So that's positive 10y. So, after we have done that, what should we do next? We are now going to differentiate that equation, our new equation, in terms of y. We are going to differentiate that in terms of y. So it will be TC or dTC over dy is equal to, this is, remember, is a constant. So, and this is squared here, sorry. I forgot a power. So if we differentiate this one, it will be the power to y is 1. So 1 times 26 is 126. Then the 1 there will be subtracted by 1. That's a rule. So it means 1 minus 1 is 0. So our y will be powered to 0. And any number powered to 0 is 0. So it means the y will go. Next, we are going to say plus 2 times 10. That is 20. That is 20. Then our 2 there, our power will be subtracted by 1. And it will be y, 1y. So it will be like that. So we have formulated that equation for what? For our we have differentiated that equation in terms of y. So the next thing that we are going to do is we are going to equate this one to 0 is equal to 0. Then we are going to say what I've done is not true. What I've done is not true. Okay. It's true. It's true. Here is negative. Right? We are taking this one as negative, right? 126 is a negative number, right? Yes, it's a negative number, this one. So it will be negative 126. So if we solve for y, we are going to say 20y is equal to this negative 126 to cross the equal sign and will be equal to 126, a positive number. Divide by 20, cancel. Our y is going to be 126 divided by 20. Our y is going to be 6.3. So that is our value for y. Now, to solve for x, we are just going to take our constant equation, which is x is equal to 18 minus y. So x is going to be 18 minus 6.3. So our x is going to be 18 minus 6.3. 18 minus 6.3 is going to be 11.7. So our x will be 11.7. So that will be that would mean we have solved that constraint problem using the substitution method. Thank you very much. God bless you.